Okay, we're question 1D. This is the 2012 one. Calculus. The fuel consumption F of a car in litres per 100 kilometre. Okay, so F is in litres per 100 km. Is related to the velocity V. So here we've got the V. And velocity V is in kilometres per hour. Okay, that's cool. That's our V. Sweet. Show the fuel consumption as a minimum. This is bold. This is saying to me, think, minimums. Minimums, the gradient is 0. So if I derive and equate the gradient to 0, I'll find the x-coordinate of when there's a minimum. Okay, so what do I have to do first? I need to derive. So df by dv, because I'm actually deriving to find the gradient function, I am deriving in terms of v. So the 16 disappears. I'm going to have 0.2, and then I'm going to have plus, I take the power down by 1, and I've got, I'm going to times that by 2, so 2 over 250 is the same as 1 over 125. Okay. So now what I want to say is the minimum when df by dv equals 0. So 0 equals that. Oh, let's get that right. V over 125. So 0 equals that. Okay. So 0.2, bringing this to that side, times 125 is going to equal v. So my velocity is going to equal, if I double it, I get 250, and then I need to divide by 10. So I think I've got a velocity of 25. I'm prone to making mistakes. Let's not beat around the bush. So I need the belts and braces kind of idea here. Okay, so what I'm going to do is I could go dy by dx of 16 minus 0.2v plus v squared divided by 250. And what am I subbing in? Oh, my velocity of 25, and I'm hoping that I've got a gradient of 0. Yes, I do have a gradient of 0. So that's pretty cool. Now the other thing I could do is go into my graph and graph this 16 minus 0.2v plus v squared divided by 250. And wow, what happened there? Something strange. Have I got that right? 16 minus 0.2x plus x squared divided by 50. Draw that. Let me see, view window, I'm just going to go standard for a minute. What happens there? Nothing, I bet. Zoom, auto. It's going to, oh, that's maybe better, maybe not. It's not really showing me what I want, so I'm just going to zoom out. Ooh, zoom, zoom out. There. Shift, view window. If you don't like it, you really have to do it yourself, don't you? Fuel consumption. Shall we go x minimum there? Let's take it up to 50 and let's go x max, x min. I actually want to y min. I actually want to see it go negative. I want to see my axes, and there I'm going to do 30 and see if that gives me something I can work with a bit better. Okay, G solve minimum. The minimum velocity is 25, and I've got 13.5 in there. Okay, so different ways of checking on your calculator. Alrighty, show that the fuel consumption is a minimum when the velocity is 25. So have I showed that? How can I prove it's a minimum? I could draw a little graph with that point, 25, comma 13.5. Okay, I could derive again. So if I've actually got this, if I derive again, I actually find that the gradient is, well, d squared f by dv squared. So deriving again, I just get 1 over 125, which is positive, which actually means it's the right way up parabola. But we knew that anyway. Let's see how much we need to actually gain credit. Justification. So that's where you want to have your graph or your double derivative or something like that. That there is greater than 0 is a minimum. That's your justification, and that was my d squared over d, was it d squared f over there. Okay, the double derivative though. Okay, and maybe the word turning point. Oh, shape of the parabola could have done too. You could have just talked about shape. Now, for achieved, all you had to do was differentiate. So this bit here was enough to achieve. So your excellence, you just got to put a few extra words there, really. Sweet. Just checking my syntax there for this double derivative. It's perfectly good. My memory serves me well. And I just had a bit of a scan through Maths is Fun. There's some actually really good stuff here that's worth having a look at. And remember, with Maths is Fun, you can actually do their questions as well, which are very cool.